All right. First, let's revisit domain. What does domain mean? X. The x values of the function. Okay, domain is the x value. So whenever someone says, what is the domain of the function? They're really, in a way, asking, what can x not be? Okay, so in other words, what can x not be in the function? Instead of saying, oh, x can be everything but blah, blah, blah. You just tell them x is not this, but it's everything else. Okay, so there are two areas that you have to check for domain. First one, the denominator cannot equal 0. That is the first rule. Denominator cannot equal 0. When it equals 0, the whole function is undefined. So we cannot have a denominator with 0. All right, so that goes with eggs on the plate. Egg can go on the plate. So this is the egg and the plate. That's okay. So 0 can go on top of a number. But plate cannot go on the egg. So what happens if you put plate on the egg? The plate will fall and the egg will break, or either one. But you cannot have something go on 0, okay? Egg goes on the plate. Plate doesn't go on the egg. Okay, so let's look at it. Let's do some problems. Number 1, y equals 5 over x. Y equals 5 over x. So the first thing you ask yourself is, does the denominator have some kind of x in there? Does the denominator have x? Yes. And then we said the denominator cannot equal 0. Right? Plate cannot go on the egg. So the denominator cannot have a 0. So then, what is the domain? The domain is x is not equal to 0. So when they say, what is the domain? Meaning, what can x be? You tell them, x can't be 0. Meaning, it can be everything but 0. Okay? Try another one. Y equals 6 over x minus 3. Is there a denominator with x inside? Yes? Okay, and a denominator can't equal what? Okay, yeah, denominator cannot equal 0, so then x cannot equal what? 3. Basically just solve it, so x can't equal 3. Let's try another one. Number 3, x over x plus 6. The question is, what are you looking for? The numerator or denominator? Denominator, so denominator can't equal what? Okay, denominator can't equal 0, so x can't equal negative 6. Do we care about this x in the numerator? No, because egg is okay to go on the plate. You just can't have plate go on the egg. Okay? We don't care about the numerator. All right, let's have you practice 1, 2, 3. Number 1, x is not equal to 0. Number 2, x is not equal to 10. Number 3, is there a denominator? No, so all real numbers. There's nothing that's going to break this whole thing because there is no denominator. Okay, so that's the first thing you check. Is there a denominator for domain? Number 2, you want to check the radicand of a square root. It has to be greater than or equal to 0. The radicand of a square root has to be greater than or equal to 0. Okay, first of all, what is a square root? How does square root look like? Like this?
Looks like a weird long division symbol.
Oh, yeah, okay, yeah, that's a weird long division sign. Okay, is this a square root?
No.
No. Is this a square root? Okay, square root has to be second root, right? Okay, please make sure you only apply this to square root. What is a radicand?
Thing inside.
The thing inside. So this thing inside has to be greater than or equal to 0. What happens if it's less than 0? Less than 0 means you get imaginary numbers, right? Because it's inside the square root. Negative numbers get square root. Okay, I'm sorry, imaginary numbers. So when you have questions like this and it says, what is the domain? Okay, so now we have a square root. Inside the square root has to be greater than or equal to 0. So then you just solve. X plus 1 has to be greater than or equal to 0. So x is greater than or equal to -1. So the question is, what is the domain, or what are all the x values? You say x has to be greater than or equal to -1, or else it would make it negative. It would make it imaginary. Okay? So when you have a square root, check the radicand. Okay, number 2. What is the domain, or what are the possible x values? What do you make, what do you do, I guess? Make this part greater than or equal to 0. Okay, so 3 minus x is greater than or equal to 0. Just solve, so 3 is greater than or equal to x, right? And then I usually write x first, so I'm going to switch the order. X is less than or equal to 3. Okay, any number bigger than 3 is going to make it negative. Okay, let's have you try 1 and 2. Number 1, this part has to be greater than or equal to 0, so x is greater than or equal to 6. Number 2, is there a square root? No, it's a cube root, so it's all real numbers. Okay, please be careful. All right, let's have you guys practice everything on the next page. Number 9 is an advanced question. I think you guys should give it a try. Okay, 1 through 9, let me know when you're done with everything. All right, number 1, Giselle.
X is greater than or equal to 10.
Good. Number 2, Andrew.
X cannot equal -10.
Good. Rula, number 3.
X not equal to
Good. Chad, number 4.
X equals all numbers.
Good. Number 5, Sebastian.
X cannot equal 1.
Number 6, Andy. Huh? At least 10 or? -10. All right, Alana, number 7.
X is not -1, and x is not 2.
Alice, 8. Don't know. Okay, this is the hard one. What'd you guys get?
All real numbers.
All real numbers. So the question is, can this be 0? Right? So x squared plus 1 equal to 0. Well, let's check. X squared equals -1. So x is equal to plus minus square root -1, which is plus minus I. The question is x plus minus I going to show up on your graph? No. So it's impossible to have a number make it 0 unless it's imaginary. Well, so it's not possible to have imaginary, so it's all real numbers. Number 9, did anyone get number 9? That's an advanced question.
X is greater than 6.
X is greater than 6. Y is, greater than 6. Okay, so this is a 2-issue problem. First, we have a square root. So we know that it has to be greater than or equal to 0. However, this square root is also in the denominator. Denominator can't equal 0, so it is just greater than 0. Okay, first you have a square root. has to be greater than or equal to 0. But this square root is also in the denominator, so we also cannot have a 0. So it's just greater than 0. All right, let's go on to 8.2. So we are going to do the rational function or the reciprocal function family. This is the parent function. The parent function, so every chapter we do a parent function. This time we are going to do y equals 1 over x. Y equals 1 over x is our parent function for this chapter. So let's look at this 1 over x function. What's happening in the denominator? What's in the denominator this time? X. Because x is in the denominator, we're going to have a lot of problems because things are going to make it 0. Okay, so that is the function we're going to do this time. And you can see that we're going to have a lot of transformation just like before. All right, let's talk about some vocab. X-intercept. X-intercept is when what happens? Y equals 0, very good. And then y-intercept is when what happens? Good, x equals 0. All right, so just kind of some vocab. Domain means the values for what? We kind of just did that. Huh? X, yes. Okay. All right, so basically, what can the denominator not equal to? So we're going to set the denominator equal to 0, and then we're going to solve for x. Okay, so we just did that for like 10 minutes or so. All right, next, we are going to look at range. What does range mean?
Y.
Y. The values for y. Okay, and then a lot of people asked me this question when you were doing homework. Asymptote. Okay, so vertical asymptote. The way you read this word is asymptote. The P is silent, so please don't read asymptote. Or a lot of people learn like chemistry, and then the next year they would just say asymptote. It's not isotope to a certain chemical structure, but anyways, it's asymptote. Just like there's a lot of words in the English language that's really strange, like this word. How do you guys read this word? Oh no, B is silent. It's debt. Okay, so don't go to college reading debt, or don't go to your career and read debt, and it would be very sad. Or like receipt, it's not receipt. So there's some words that's In 8th grade, my history teacher said, I don't want you guys to be an embarrassment in high school. I'm going to teach you all the words you shouldn't say. You should say correctly. Like, don't say compromise. It's compromise. Or like, what's it, colonel? It's colonel. So, those kind of words. So don't embarrass yourself reading the wrong words. So, asymptote. Okay, can everyone say asymptote? Okay, say that again. Asymptote. Okay, so don't say the P, okay? All right, vertical asymptote. Vertical asymptote, vertical is this way, right? Up and down. So this is the vertical line that the graph cannot cross. And that is usually the domain problem, so the domain restriction. Usually. This chapter gets pretty tricky because we have to check. Sometimes it's not the domain restriction. Okay, next. Horizontal asymptote. Horizontal is this way, the left and right. So this is the horizontal line that the graph cannot cross, usually. It crosses sometimes near origin. It gets kind of crazy. Asymptote usually means the graph cannot cross it. Vertical asymptote, it will never cross. Horizontal asymptote sometimes. So sometimes when you graph it, you're like, wait a minute, Miss Young says you can't cross it. Why is my graph crossing it? It can sometimes. So be careful on that. All right, let's look at this question. Graph this function, identify the following parts. All right, we're gonna do the whole analysis first before we graph this. Okay, so let's look at this function. This function is a reciprocal function because the parent function is 1 over x. Okay, so notice there's like a little 1 over x here. There's like a 1 there. Okay, so what is the first thing that happens to this graph? Starting from 1 over x, that is the parent function. What do I do to move this function? What's the first thing that moves? Remember, whatever moves is closest to x. Right 1. Okay, can you see that there's a minus 1? So we're going to move left and right, which is going to be right 1. All right. Next thing. What is the next thing that happens to this function? It's that 8. What does that 8 do? Stretch 8. All right, that is the second thing that happens. The last thing is this 2 at the end. What does that 2 do? Yep. Up to. All right, so this is what's going to happen to this function. We're going to move right 1, stretch 8, and then move it up 2. All right, let's look at domain. Okay, kind of like what we practiced 20 minutes ago. What can x not equal to? Sebastian, you're too fast. Okay, I think you're going to just count to 5 next time and then answer. Okay, x cannot equal 1. We're going to do the range a little later. X-intercept, y-intercept. All right, let's try that. Let's do y-intercept first because that's easier. Y-intercept is when x equals 0. Okay, so we're going to solve when x is 0. All right, go ahead and figure out where is the y-intercept. Where is the y-intercept? Just solve that equation. Evan, do you have the y-intercept? -6. Okay, so 0, -6 is the y-intercept. Okay, x-intercept. X-intercept is when y is 0. Okay, so we're going to make y 0. So 0 equals 8 over x minus 1 plus 2. This one looks a little bit harder to solve, but it is not impossible. What should we do first to solve this? This side of the room. This side answers a lot. What should we do first? Move the 2. Very good. Minus 2 is equal to 8 over x minus 1. What's next?
Multiply the x minus 1 to the other side.
Minus 2 times x minus 1 equals 8. You can solve this one, right? Yes. Okay, go ahead and figure out where the x-intercept is. Okay, Nathan, did you get the x-intercept? Yes, -3, 0. All right, we're going to do the vertical asymptote and horizontal asymptote a little later. Let's graph this. Okay, I'm going to show you how the parent function looks like, and I'm going to move it according to the transformation. Later on, just graph the equation as is, but you should try to see how it looks like from the parent function. Okay, so we are going to graph y equals 1 over x. Anytime we don't know how this looks like, take out your xy chart. We're going to graph the very basic 1 over x. All right, so if I put -2 in the function, what do I get? When x is -2, what is y? -1/2. Okay, if I put -1 in the function, what do I get? Everybody. -1, very good. If I put 0 in the function, what's going to happen? Huh? Undefined. Nothing goes on there. Okay, if I put 1 in there, what do I get? 1. Okay, if you know the answer, just answer. It will make our class look more lively. Okay, if I put 2 in there, what do I get? 1/2, very good. All right, let's go ahead and graph all these points. -2, -1/2, -1, -1, 0, there's nothing, 1, 1, 2, 1/2. It's not a very interesting graph. 4 points. I don't even know how they connect. Okay, so this kind of graph, you have to memorize how it should look like, because if you don't, it's really hard to connect the dots. Okay, so first, we know that it's undefined at 0. So x cannot equal 0, which means there's going to be a vertical asymptote at 0. The way we draw x equals 0 vertical asymptote is we draw a vertical line at 0. But the way we draw the line is we put dotted line to say that it's invisible, but you cannot cross it. Okay, the second thing that happens is there is a horizontal asymptote on this parent function, and I'm going to just tell you where it is. Next year, we're going to figure out why it has to be there. If you really want to know, you can stay after. I can tell you why. But for now, just memorize that it is at y equals 0. Y equals 0. So we have two asymptotes. One is at x equals 0. One is at y equals 0. This is standard. You just have to memorize that's how the parent function looks like. And we're going to move things around later. Okay, we have 4 points. The question is, how do they connect? Okay, so you're going to think of asymptotes as if they are magnets. The magnets are going to pull the graph towards it. But you know how magnets are? If you're really close, if they're like different polar, they are going to push it away. So it's actually never going to connect. It's just kind of going to go really, really, really close to it. So the graph, so for example, this side, this asymptote is going to pull this graph towards it, but it's never going to cross. And this side is the same. It's going to pull towards it, but it never crosses. Okay, so just, they have to go towards the asymptote. The same thing on this side. It's going to go towards the asymptote, but never cross. And it's going to go towards the asymptote, but never cross. So that's how the basic parent function looks like. You have to remember, again, you have two asymptotes, like across. And then you have two lines, first and third quadrant. And you're just going to move things according to the transformation. Okay, so let's graph our transformation. So according to this graph, this equation, we're going to go right 1, stretch 8, up 2. Right 1, stretch 8, up 2. Okay, so let's think about it. If I move right 1, my vertical asymptote is going to move right 1. Yes? If I move up 2, my horizontal asymptote is going to move up 2. So my new asymptote is going to be at x equals 1 and y equals 2. Yes? Okay, so this is my new asymptote because I moved right 1 and up 2. Bless you. And then my whole graph is going to move that way. And then what's going to happen is it's going to stretch 8. So the number, right here, it was 1, 1. I'm going to stretch 8, so now it becomes something, something 8. So basically moved right 1 and then it went up to 8. But we can use the points to help us. So remember that you did find an x-intercept and a y-intercept. So the least we can do is at least put those points on the graph. So negative 3, 0 is on the graph. Negative 3, 0. And 0, negative 6. We know for sure those points are on the graph. We don't really know where everything else is, but at least those two. So we know that, again, the asymptotes are going to pull this graph towards it. So it looks like that. The other side, if you want to be very accurate, you have to put in the numbers. If not, you can just draw this and it's fine. We just want to know a general shape of this graph. It doesn't have to be super accurate. Okay, graphing is the hardest part of this whole chapter. So let me know if you have any questions right now. Okay, summarizing this. 1 over x is the parent function. It always has two asymptotes. X equals 0, y equals 0. And then we're going to move things around based on the transformation, and then that's going to move the asymptotes. The asymptote always pulls the graph towards it and never crosses it. Okay, let's answer all the questions we skipped. Range. What is the range on this graph? The red graph. What is the range on this graph? Let's have you talk to your partner so it's not just only one person answering. Talk to your partner. What is the range on this graph? What do you guys think? What is the range? What can y equal to, or what can y not equal to? Good. Y is not equal to 2. Because that is the horizontal asymptote. So if you look at the red graph, the graph is never going to cross y equals 2 because that's the horizontal asymptote. Yes? Okay. Okay, so now let's write the asymptote. Vertical asymptote is the vertical line. The vertical line is at x equals 1. So basically your domain was not equal to 1, but then your asymptote is at 1. So where is the horizontal asymptote? Y equals what?
2.
2. Y equals 2. Sebastian, remember to count to 5. Okay, next question. How are you supposed to know all that from this equation? Right, you don't want to graph every single time. Okay, well, let's look at this equation again. What is the domain? Domain is not equal to 1 because of the denominator, right? What is the range? The range is according to this number. Because it was not equal to 0, that was the basic one. And when we moved up to, that horizontal asymptote moved. Okay? And then the vertical asymptote and the horizontal asymptote is according to those green parts as well. Okay, again, the graphing part is probably the hardest one. Okay, let's do another one together. What is this graph? Identify the following. Okay, so let's have you try the transformation first. So just the transformation part should be pretty easy. All right, let's start with Isabella. What is the first transformation?
Left hand.
Good. And then Daniel?
Stretch one.
Yes and no. One is really not a stretch. It's just like stay as is. So what's the next one? Good. All right, let's look at domain and range. Let's see if you can figure out domain and range. All right, Josh, can you give me the domain?
X not equal to
Good. X not equals -1. And Samantha, can you give me range?
Range is not y equals negative 2.
Good. All right, let's try x and y-intercept. X-intercept is when y is 0. Y-intercept is when x is 0. So try solving those. All right. Brady, do you have x-intercept?
negative 1/2 0.
Good. And Mark, do you have y-intercept? Not yet. Sally, do you have y-intercept? 0, -1. All right. Let's have you guys fill in the vertical and horizontal asymptote as well. Those should be pretty easy. They are just the domain and range in this case. So vertical and horizontal asymptote. Okay. Mark, do you have the vertical asymptote?
X equals -1.
Good. And then Blake, do you have the horizontal asymptote?
Y equals -2.
Good. All right. So we are going to graph this now. First thing you want to do is always just get your asymptotes on there. X equals -1. Y equals -2. At least those, right? At least get the asymptotes on there. Second thing is you want to get all the points that you know on there. The only points that we know are the x and y intercepts. So at least get those on there. -1/2, 0, and 0, -1. Next thing is just try to draw the graph as best as you can. If you want to know exactly how it looks like, you have to put in more points. But at this point, it is as good as it is. So we're going to connect those two dots. And the line's going to go towards the asymptotes. And the other side is going to be the same. Just remember, they're always across from each other. And that's it. Okay, let's have you practice one on your own. So let's have you guys try the next one. Let me know when you're done. Okay, let me give you some of these so you can check. Okay, transformation is right 4, up 6, domain x not equal to 4, range y not equal to 6. X-intercept is at 23/6, 0. Y-intercept is at 0, 23/4. Vertical asymptote is x equals 4. Horizontal asymptote is y equals 6. So get those asymptotes on there first. (23/6) is almost 4. So somewhere here. 23/4 is 5 point something. So something like that. And then on the other side. Can't see what's going on there, but that's how it looks like.